how to set up your equation in calorimetry problems. So there are 3 different scenarios, and the first one is a heat of reaction. So you are given information that there is a reaction and there is a solution. And now they are asking you what is a heat of reaction. So keep in mind that only the heat of solution is measurable. So the MC delta T that you're going to input is only for the Q of a solution. That means if you want the reaction, it's going to be the reverse of a sign. So when in problem solving, you will check down what they have given you, reaction and solution. And you might note that the temperature of a solution is decreasing, which means the solution is exothermic. And then you will calculate your Q of solution, flip a sign to get your Q of reaction, which is also the heat of reaction, since Q is practically equal to H. Another scenario is melting and fusion. Instead of just Q of reaction is equal to Q of solution, you also have a phase change. So you would take into consideration of this part. They will give you the H of fusion, which is the enthalpy needed to go from the ice to a liquid form at 0 degrees. Maybe this is -5 degrees-ish. So this accounts for this first part. And then you have to still keep the Q here, because this will be the temperature of the just melted ice into the water that is being heated up. So this would be an example where you have a hot cup of tea and you're adding some ice into it. And instead of just writing H of fusion, which they might say, I'm just going to make up a number. If they say it's 4.9 kJ per mole, you want to make sure that it's in the molar form. This is a very generic way of saying it, because they could tell you that there is like 0.15 grams of ice. So then you might want to find out how many moles that is, and I'm making this up. Maybe there's only 0.1 moles, which means your enthalpy here is not going to be just this number. It's going to be the mole times this, so that will account for your total Q. Okay, so NH is equal to the Q as well. Another scenario is they can ask you, what is the final temperature of this problem where you do have a reaction and you also have a solution? But they also tell you some weird information about the heat capacity of the calorimeter. If they tell you the heat capacity of the calorimeter, you will need to use it. So you would need to put it on the solution side, because that is also the heat gained by the system. And you would use this formula. So this is the heat capacity times the change in temperature, and the initial temperature is just going to be the same initial temperature as the solution. In problems where they ask about the final temperature, what will end up happening is you will end up doing some distribution, so be prepared for that. And that's all I have for you today. Hope this helped.